Hello and welcome to the fourth tutorial in the series of tutorials that will help you build SlopeBlend effect in CryEngine. This tutorial is taking off from the last tutorial where we calculated the SlopeBlend or the slope of the vertex normal so that we could get this black and white mask which defines the areas in which the normals are facing most up. Okay, so the next step that we laid out in the previous tutorial is to take this mask that we are generating and we're going to refine it and add controls. So in the second tutorial in this series, we added the deviation, mask strength, and the threshold parameters, and this is where we're going to kind of put this into practice. We need to write a function that will take in the mask, and when it takes in the mask, it needs to basically we're going to be taking an input height map and we're going to be using that to break up the edges where these hard edges are, because this does not look very natural. You see a lot of pointy shapes and triangles and things like that, so we're going to try and get rid of a lot of that. So we're going to bring up our code and we're going to go up to the area where we defined our generate SlopeBlend mask function, and we're going to write a new function, and this needs to return also a half. So we're going to let's call this soft threshold. Okay. Now this needs to take in the input value. So this is going to be the input mask. So actually we can call this input mask. And we need to bring in our threshold and our deviation. Okay, let's set up our brackets. Okay, this is a bit tricky because we're going to be doing a lot of pixel processing in this function. We're going to start out by defining the minimum threshold value. So let's write a new variable, and we're going to call it minimum threshold. It's a half type, and we're going to calculate the minimum between the threshold and the deviation. And then we're going to assign the 1 here, which basically is the max. Let's not forget to put the semicolon. I will probably do it a few more times, but hopefully not as much right now. Okay, so our output, so basically what we're doing is we're calculating the minimum threshold amount. It's basically going to subtract the threshold from the deviation, and we're going to get the lowest amount of any pixel. Basically, you have to think of this function as taking in a single pixel, and we're calculating all this on a single pixel, which is how pixel shaders work. No pixel is aware of the other pixels, so all of these functions, when it says half, it's really, you can just say that this half here is a pixel, and we're inputting a pixel into this function, which is a program, basically, and then these operations are all running on that pixel. Not the whole texture, not the whole anything, just a pixel. That's important when you have to think about the math, because we're not dealing with we're not dealing with comparative math, comparative structure. So I'm using so we're going to define an output variable. I am actually using a blending method that is pretty similar to kind of a terrain blending method, and this method can be changed up a lot, but I got this particular one, I believe, from a shader graph in Unity that's someone else made a long time ago, and I don't remember where I got it from. I will try and find the source in the link. I will try to find the source, and I will link it in the description. But okay, so what we need to do, and we do need to clamp these whatever we put into here, because the value needs to be between 0 and 1. So first let's start by implementing our input value, or input mask rather. And we're going to subtract the minimum threshold. So think about how, say, Substance or Photoshop works, and the best way to think about it is that we're taking the mask that's coming in and we're running a subtraction. If you went into Photoshop and used subtract, then we're going to subtract this value from this mask. So this is going to give us kind of a control over brightness of a particular area defined by the minimum threshold value. Next, we need to divide that, what we just made, and we need to divide it by, we're going to create another brackets section here because we need to define this as two separate math operations that will then be divided together. And we're going to say I want the max value between the 0, which is going to be the min, and our threshold plus deviation. So you'll notice that in this case we're getting the max threshold and not the minimum threshold. The reason I'm doing it in here is because we don't want to be defining a ton of variables. So really I could come in here and say half max threshold is equal to max threshold plus deviation, and then I could just put max threshold in here, which would definitely reduce the confusion factor, but we want to stay efficient. We want to think about this in an efficient way. And if it's still confusing, then I can break out more into separate variables so that it's less confusing. But okay, then we need to go outside of the max function, function which runs and gets the maximum threshold value, which is the threshold plus the deviation, and we need to subtract it by the minimum threshold. And then, since this is a clamp function, we are going to have to clamp it between 0 and 1. Okay, and next we need to return output. Alright, so I'm just going to run over this real quick, just to make sure that it's interested as best as it can. I am not particularly sure on the specifics of this one. This was very difficult for me to get a grasp on when I was making it, and Ivan actually helped me kind of compress this down into this format. So we're taking our minimum threshold, we're calculating it. It's the threshold minus the deviation, and then we are calculating our output, which is a clamped version, which basically means, and this function here, it clamps the value between 0 and 1. So it's kind of like the saturation function, which looks like this. It's similar, only clamp allows you to define other values. I like to use clamp when it needs to be specific language, so I know exactly what's going on. So we're clamping the input mask minus minimum threshold. So we're already in this section of the math, in these brackets here, or parentheses rather. We are subtracting from the input mask the minimum threshold value, which is assigned in the material editor. This creates kind of a curve. You can graph it. If you graph these numbers, you will see that it creates a curve. And that's what we want. We want to sort of blur out the edges. And then we divide that by the max value between the threshold plus deviation minus the minimum threshold value that already exists, which is why we need to define the minimum threshold value before we have it in here, instead of just trying to define it inside of here. Because that minimum threshold value is taken into consideration, as well as the original threshold and deviation values. And then we clamp that by 0 and 1, between 0 and 1. So then we return the output. So now we have a function that takes a input texture, a threshold value, and a deviation value, and we're going to assign this function to our mask down here in the main part of our code. So we have our slope mask. So I'm going to create another line here, and we're going to say slope mask is equal to soft threshold slope mask. I believe the first one was threshold and then deviation. Okay. So we just run that into our function for soft threshold. And we run the slope mask that we generated here into the function, and then we have the threshold and deviation values which come in from the ilum.cfx. If you recall, we created this section here, which is all our parameters. So you just need to make sure that the spelling and everything is correct. So we have threshold and deviation. So I'm just going to copy and paste just to make sure. This is a very good habit to have. Okay, so I'm going to save this. I'm going to take one last look to make sure I didn't forget any end of line semicolons. Looks good. Half, 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 half. Output's half. Turn output equals, yes. Okay, that all looks good. So let's go in here and let's reload the shader. Okay, we've got an error. Invalid subscript, Y. Minimum threshold. Let's go out to our here. Invalid subscript Y. Where is this? It's in the half min threshold equals min. It's in the minimum threshold. Okay. Half min threshold equals min. Sometimes this has nothing to do, the error has nothing to do with what's actually wrong, because this line looks fine as far as I can tell. Oh, yeah, no, that's fine. This all looks good. I'm not using any .y's anywhere. Okay, let's go down here, and I'm going to comment out this. We're just going to work through and figure out where this error is. Okay. Okay. So yeah, it's definitely in the function. We're going to have to uncomment this then. I'm just making sure I didn't mess up anything anywhere else. So I just temporarily got rid of the function to see if I maybe messed with something outside of the function that's causing this problem. Invalid subscript Y. It's telling me, if you look at the asterisk here, it's telling me that in the half min threshold, apparently there is a problem. Mask strength tester.y 1. Okay, why am I getting a tester.y in there? That shouldn't be in there. Is this in? It's in the common ZPass. Common ZPass shader. Okay. Let's go back up here. Did I type in the wrong? Okay. Oh, that looks good. Threshold, deviation, mass strength, tester, mass strength. X, Y, Z, W. They're all separated. They're all different, so I'm not reusing any parameters. This is a new problem. Never seen this before. I'm probably just overlooking something really simple. Let's do a quick test here. No, it's all good. Okay, I'm going to pause the recording and see if I can figure out what this is, and then we'll go up right after I figure this out, and I'll explain what the problem was. Alright, I solved the problem. Turns out it was, I was just passing the variables from here, these variables, into the function itself. Apparently, as of 5.5, this is not acceptable behavior because they already exist in the main shader. Because this is a include file, those would have had to have been inside of the include constant definition. So I would have to put them inside of these constant buffers for CFI files. Those are two distinct things now, so if you've had that same problem, then to fix it, we basically just remove all of the inclusions of those variables inside of this function call. Well, the function call is down here, but come on. So inside of this function call, just call the slope mask. Any variables that you have assigned in here will need to be only called in your function call if those were defined here. So for instance, if you define them like this, half dev, half threshold, and then you pass them, you will then have to pass them through here. So sorry for that little sidetrack, but like I said, I think including this stuff is important so that just in case you run into similar issues, you have an explanation of why this is a problem. So I'm just going to get rid of this, which I added earlier. And now we can look at the effect. So we have our deviation slider. So basically what this is this it acts as a little bit of a sharpener, but since this is an average, if you recall, or a minimum value, then the threshold, the higher the threshold is, the softer that value will be. So then the deviation will simply control the spread of that, and the higher the value of deviation, and the less the threshold will have an effect on it. So threshold is mostly for low values to kind of create a sharper deviation, a sharper transition. So like if you had really sharp snow or something, and you wanted to have these like clumps of snow, then you could do that. So, all right, that is basically just one part of this whole situation. We still need to add the mask breakup. So I'm going to add a height map here, and I'm going to go to, let's see. I don't know if I have, do I have? Yes. So here I have a RockBlend Moss blend map. So I'm going to add my diffuse into here and my normal into here so we can kind of prep this situation. Now that I have the height map, I can go into my code, and here it is right here, and we are going to multiply. We're going to start simple, so we're basically just going to take that same slope mask, and we're going to multiply equal, so basically it'll iterate over, and this way we don't have to basically we don't have to type it like this, slope mask is equal to slope mask times whatever. It's just times equals, which is very helpful shorthand. And we're going to do that by the slope height. We're going to need to assign a parameter. So we can do this. We can put this in brackets. And we're going to assign that slope, I believe it was slope mask strength, I think is what we made that in the ilm.cfx file. Nope, just mask strength. Okay. Mask strength. Okay, simplified it a little bit. Let's save that. Let's go back to the engine. Reload the shaders. Okay. compiled correctly. Let's see if our mask strength has the intended effect. Okay, so right now it's literally just cutting out that texture on top of it. The best way to see this is going to be, we're going to hook up our tester function up to the UVs for this. So let's look at, so here's the variable here, tester. So in here for the get height text, we're going to say in.basetc times tester. Save. Get up shaders. Alright, so basically what we're doing is we're using the tester to adjust the tiling, the texture tiling. So you can see, you can already tell how much that really breaks things up. And when we assign a more complex methodology for the mask itself, how the mask will affect, whether the mask will just grow or shrink the mask or just affect the edges, we can do that in the next tutorial. So thank you for watching this tutorial. This was a long one because we had a few issues, but that's good. It's great for learning. So I will, in the next tutorial, I will be going through some of the more advanced stuff. We're going to actually set up our diffuse and normals, and then we're going to adjust how the mask is affecting this blend layer effect. Okay? So see you in the next tutorial.